In this tutorial 6, I will be looking at a three-step sequential load which involves a contact interference or interference fit problem. The idea behind this particular problem came from a reference that's seen down here. It's a more elaborate version of what I'm going to be showing you. However, there are certain things that I felt that needed more explanation. Therefore, I decided to kind of replicate that particular tutorial. It has to do with the following situation. You have three parts here. There is the yellow part, which I will call the outer tube. There is the green part, which I call the inner tube. And there is this orange looking part, which I will call C-clamp. This C-clamp is actually press fitted or pressure fitted against this uh, inner tube, the green part. And then it is pushed until it establishes contact between the C-clamp and the outer tube, and then the inner tube, the green piece, uh, is experiencing a pressure applied to it, and therefore pushes the C-clamp, which pushes the outer tube with the right face of the outer tube being fixed. So it involves three steps, as you will see. I'm going to assume that the inner and outer tubes are made out of steel, and the C clamp is made out of uh, aluminum. So here is the setup. Notice that the hole in the C clamp is a little bit smaller than the shaft of this outer tube. There is a 0.5 overlap, and that's why you have to shrink fit the C clamp onto that shaft or the inner tube. Here is a drawing. This height is this radius of the hole in the C clamp is 20 millimeter, whereas the shaft has a radius of 20.5, and that's why the shaft or the inner tube has a radius of 2.5 here, and that's why it has to be pressure fitted. Now, as far as the outer tube is concerned, it's just a standard pipe, pretty much standard pipe of length 16 millimeter. And these are the dimensions. These dimensions I'm going to be using to make this. Now, incidentally, this is an assembly, so I can actually make these pieces exactly where they're supposed to be and then start from there. Or I can make three pieces and then use the assembly three parts and then use assembly constraint to put it together. In tutorials, I believe tutorials 4 and 5 in this playlist, I actually made those parts in place, didn't use assembly constraints, but here I'm going to use assembly constraints later on. So the setup is like this. These are the three pieces: outer tube, C-clamp, inner tube. This is the side view. And when I put together, it looks like that when you look at it from the front. In step one, we do the shrink fit. This is shrink fitted into uh, uh, inner tube, which is the green piece. Step two, you push this assembly, these two pieces together. They're going to go together because one is shrink fitted on the other one until it establishes contact. The C-clamp establishes contact with that outer tube, the yellow piece, and then uh, remember that the right face of the outer piece is clamped, and therefore you apply pressure, and this whole thing gets squished. When you're doing assembly, remember, because there are three pieces to be participating in assembly, don't forget to say that they're all needed, okay? And there are some differences between the way I do this problem and what is in that YouTube reference by Go Engineer, Go Engineer, and among them, for example, they aside from the shrink fit or interference fit, they use general contact to establish the other surfaces being in contact with each other, or use surface-based contact. And also notice that in order to avoid rigid body motion, I will create a a reference point for the C clamp. The location of it doesn't matter, but I'll make it at the center of one of these circles. And you're going to say that the surface, the inside surface of this hole is kinematically coupled to that reference point. All translation, all rotations are coupled. And also, in order to prevent rigid body motion, in step one, actually, I will fix that reference point so that it cannot just wobble around. Now, these rotations are totally unnecessary because rotation is not a degree of freedom for a solid element. So in tutorials 4 and 5 in the playlist, I actually check them, but here I'm not going to do that, okay? So let's go through step one, the shrink fit stage. Uh, what we'll do, I will, to prevent, notice that this outer tube, this big piece, is not going to be doing anything, is participating, because all it is that this is shifted into the inner tube, okay? So in order to prevent rigid body motion, I'm going to take this face and prevent it from moving in the X and Z direction, and in a separate restraint, I'm going to prevent it in going from Y direction. But basically, this face is clamped. However, I will do it in two separate uh, uh, separate. I will not clamp it because I want to be able later on to release something. Okay, so one restraint like this, another restraint like that. These are boundary conditions, and the clamp, the reference point, I'm going to prevent it from moving in the horizontal direction, in the Y direction, okay? Stage two is when I move the string translated to the right by 20 millimeter until it establishes contact. And when I do that, in order to make the translation, obviously you have to remove certain things. You have to delete these two boundary conditions, because otherwise this thing cannot move. So what I will do, I will remove these in step two and then run it, of course. And finally, when we get to the pressure, this right side is fixed, and this face is applied, is subjected to 100 megapascal of pressure. And of course, to convince you that actually there is, this thing does actually show stresses in it, here I've separated, as you can see. And remember, we have to take the translation off, because the purpose of that translation in step two was just moving this thing so it barely establishes contact. So make sure that that is removed from the boundary conditions in step three. The meshing is done with a linear tetrahedral element. You can see that with these dimensions. And that's pretty much it. So let's go ahead and do the problem. Here's the interface, 3D experience interface. Okay, so let me insert my first part. Right click, insert. I will do the inner tube first. So 3D part. Okay, and I will call this thing inner tube. So that's properties. Call this thing inner tube, which is that green piece. Inner tube. We're going to make it. So let me move to the 3D shape, and on that vertical plane, I will sketch this thing, okay? So let me first make a rough shape for it, and then we put the dimensions in a minute. Okay, get through this. All right, so let me see now. Uh, these are horizontal, which is good. This must be vertical. Right click. Uh, okay. All right, we can clean it up. So let me click on. Uh, let me select this. A vertical. Some of these things are not good. This one vertical. This one vertical. Okay, very good. And that's pretty much it. So this angle must be 90 degrees. I'm pretty sure it is, but I'm not going to check it out. Let's put some dimensions here. Now this is, based on the drawing that I have there, is 50 millimeters. Okay, this is 10, that is 10, and this is 20. All right, and there's something else there. Oh, this dimension from here to that axis is 20.5. Remember, it's half a millimeter fatter than the hole in that C-clamp. Okay, good. Now, I want to do a revolve this thing, and since I didn't close that, the easiest way is to create an axis system, or axis here, not axis system, an axis here, a horizontal axis. It doesn't matter where it is, as long as it's horizontal, it's going to take this thing and shaft it about that axis. So exit and revolve it, and that's what I want. Okay, good. So there we are. And I'm going to change the color of it to, for example, green, just so that we can see it better and matches what I have in the slides. Good. So there we are. Now this is going to be made out of steel. That being the case, let me apply steel to it. So tools, uh, create a material. I'm going to call it steel. And this is November 22, 2023. You say okay. All we need is the Young's modulus and Poisson ratio here. Nothing fancy. We refresh this right here. Apply. Close that. Apply to this. Check the green check mark, and then we put in our value. So that's going to be structural, abacus multiphysics, mechanical, elasticity, elastic, and it's going to be 200,000 megapascal, Poisson ratio 0.3. Say okay. Good. Now we're going to insert, we go all the way to the top. Let's do the C-clamp now. Right click, insert, 3D part. I'm going to call this thing C-clamp. Right click, properties, C-clamp. And here is the reference C-clamp. Okay, so we go to the part design basically. See, we are in assembly design. To go to part design, double click on this. We are in part design. So on that vertical plane, I will sketch this rectangle. So let me draw it first. And there are many ways of doing these things. It's entirely up to you how you want to do that. This height is, let me see, this height is It's that height, something that I forgot to give you here, but this is, let's make that thing 80. Okay, this height I forgot to give you is 80. Let's do that. 80. Actually, I'm sorry, 60, 60, 60. Yep. And then dimension from here to there is going to be 20. So let me move this stuff up. Okay. Another dimension from there to there, this is going to be 20. That's why there is a half a millimeter overlap between them. And that's pretty much it. So I will also draw an axis here so that it's going to get revolved about that. Exit and shafted, but not 360 degrees. So I'll make it 350 degrees there, because I want this opening to be there for visual purposes so that it matches kind of uh, this kind of a thing. Okay, the actual size of it doesn't matter. Yeah, so I'm pretty sure that's. Let me see. Let me try to make it. Yeah, that looks okay. All right, so let me change the color of that. Properties on the graphics. Go to probably this. Yeah, okay. Now, I do want to create a point here, and that point is going to be used as a reference point for this C-clamp, because in order to do the shrink fit or shrink fit stage, I have to prevent this rigid body motion here. So what I'm going to do is I'm going to create a point there. So while I'm in this part, C-clamp part, so I'm going to make a point. And the way the point is made is the center of that circle. It's right there. You can see that. Good. It's going to be made out of aluminum. So let me go ahead to tools and create a material. I'll call it aluminum. Sorry, yeah, aluminum. November 22, 2023. So right there, apply. Let me close that on this part, and we put the properties there. So we go here. The only difference is pretty much Young's modulus. So structural, abacus multiphysics, mechanical, elasticity, elastic. So I'll put down 70,000. MPa, Poisson ratio, I'll take it to be the same, 0.3. Remember, this is a problem. You're going to assume everything remains elastic. Excuse me. So, I'm not very concerned about yielding and things like that because I'm assuming everything is going to stay elastic. Okay, good. Now, we're going to go, let's do a save here. Okay, let's go all the way to the top and apply or create our outer tube. So right click properties, sorry, insert a 3D part. I'm going to call this thing outer tube. And here is the instance outer tube. We say okay, and we're going to make it. So you can draw a rectangle and shaft it, or you can draw two circles and pad it. That's how I'm going to do that. So we are in part design on that same vertical plane. Oops, not this one. On that same, on this vertical plane. namely XY. Yeah, I'm going to sketch two concentric circles, radii, let me see, radii of 160. Yeah. So let's go here. There's one circle, and this is going to be 100. This is the outside one, and there's another one. And this is going to be 60. Yeah. Exit and a pattern by 60 millimeters. Okay, so let me change the color of that to yellow. All right, so all the way to the top, all the way to the top. Save everything. And I'm going to move these things. Why don't I actually do the following? Why don't I uh, translate this yellow part, the outer tube, to the right? So we go to manipulate in the direction Y. So this is going to go there. Okay. All right. And now I'm going to put the assembly constraints. For example, oh, you know what? Yeah, I just want to make sure that this was actually 10 millimeters. I think it was 10 millimeters. I'm not sure, but let me just double check. Go to the C clamp. I can't remember whether I actually put a dimension there. No, I didn't. So that dimension should be 10 millimeter. Right there. 10. Okay, good. Exit. Okay, that's a lot better. Okay, so why don't I actually anchor this? Because we have to put this thing together, right? So let me fix this piece. Okay, so we go to engineering connections, fix, see that? Fix. Okay, so we already anchored that. You can see that. Now I'm going to put this against this guy. So let me go ahead and do engineering connections. Okay, and I will do, here's the, you can see that this is a, contact. So I want this face to be against that face right there. And then we say, okay, yeah, fine. This is the way it is. And incidentally, you know that the distance from that face of the C clamp to that is going to be 20. So when it comes to later on translating, we know exactly how much we have to translate that to be uh, surfaces to be flush. But anyway, let's move on. Now, I want this face to be 20 millimeters away from that face. So let's see how we do that. We go to, once again, engineering connection. Here is the offset. You can see that offset from this face to that face. I want it to be 20 millimeters. 20 millimeters. Say okay. And then say okay. And then update. There we are. Notice that there was a reason that I went and put a dimension here, because I wanted to know exactly how much this has to be translated later on so that this surface becomes uh, flush. Uh, yeah, so this surface establishes contact with that. Okay, good. So we are pretty much done. As far as I could have done this thing uh, initially by drawing things in position, but I decided not to. Okay, so now we're going to go to, let me get, yeah, now let's go and do the meshing step. So, oh, I forgot to apply material to this. So let me actually get out of that. I forgot to apply material to this fellow, which is made out of steel. So that is the outer tube. Yes. And the easiest way to do that is we are in the outer tube, we want to apply material. The easiest way may be this. You go to tools and you use the tester. See that? Pick material and you pick the material from this green piece, which is steel. And now we apply it to that and we say okay. So it should be made out of steel. Yep, you can see that. It's made out of steel. Or you go and do it again. Anyway, let's go all the way to the top, all the way to the top, and save everything. Good. So now we're going to go to the structural model creation, which is where the meshing is done. Empty FEM model. Now, just watch me for a second. You click on this and wait for this dialog box to show up there. If you don't get this thing or you do something else so that this doesn't come up, then you have to go and add it manually right there. You see that? Right there. But I didn't close it prematurely, so that's okay. So all of these are going to be used uh, in my model. Okay, so let's go start the meshing from the inner tube all the way down. So mesh, these are tetrahedral mesh. We do the inner one, 5, and these two numbers, these are exactly what I have here, and I suggested that we use them. Where is that? Uh, right there. We are using linear elements right there. Mesh it. Okay, good. We say okay. Now we apply the properties. So let's go ahead and apply properties, solid, on that piece, which is going to be my inner tube. I'll do it from here. Steel is picked up, so that's good. Let's go back to meshing and now do the C-clamp. So the second one is going to be the C-clamp. You select this, same numbers, mesh, okay, and properties, solid for C-clamp, which was this one, aluminous pick, good. And finally, the meshing of the outer tube. So let's go to mesh, tetrahedral, outer tube, same numbers, okay, properties, solid section, and that is this fellow, steel, okay. And let's save everything. Now let me actually go ahead and hide these elements so we can do it from here. Visibility. There are other ways of doing it. There we are. Now, and if you want, I can also hide these pieces so that I can see it better. Now, I want to create a coupling between this point and that inner face. Okay, so we go to connections. Here is a coupling. For the first one, for the first support, I'm going to select this. For the second support, I'm going to select that point that I created. Remember I created a point here? Right there. Now, it's going to be a kinematic coupling. You're not here. Kinematic coupling. But remember, these rotations are not degrees of freedom, so I'm going to uncheck them. And remember, in tutorials 4 and 5 in this playlist, I actually let them stay, but I'm going to uncheck them here. Okay, good. So I created the coupling here, and that appears in, let's check that. It appears in, not there, in here, right there. It's in there, right there. If I ever need it, I can select it from here instead of there. All right, so what is missing? What is hiding here? Let's actually go ahead and get our pieces that are in hiding. Uh, uh, yeah, so let me see now what is hiding here. Uh, Probably if I hit this. Let me see. This is C clamp, so I probably hit the shaft here, right click, hide and show, and the tube is also there. But okay, so let me also get the tube, outer tube. Okay, so that is probably there. Yeah, pad. All right, good, good. Okay, so as far as the model is concerned, we're done here. We're now going to go to structural scenario creation. We go there, and we